So we're still on sheet 9. We're now moving to question 8. Find the equation of the tangent and normal to the curve of the equation at the indicated point. Graph the function, the tangent line, and the normal lines. So graph the function, the tangent, and the normal lines. A, y is equal to x plus 3 to the power 3 at -2, 1. Find the equation of the tangent and normal. We start from there. Now the equation of the tangent line is simply an equation of a line, which is y is equal to mx plus c, or y minus y1 is equal to mx minus x1. These two methods are the same in application, where the m is a gradient, and the gradient is obtained from its gradient equation, which is dy dx, or simply y prime. So the first derivative is referred to as the gradient equation. It also has that name. So in this case, for our question, we look for y prime, which is 3x plus 3 squared. And then to find m, in this derivative, where there is x, we substitute the point. We are finding m at a specific point. So -2 plus 1 squared. This is going to be 3, because -2 plus 3. So -2 plus 3 is +1. +1 squared is q1. 1 by 3 is 3. So we have m is equal to 3. So when m is equal to 3, we can go back and write the tangent equation. So say 3x plus c. How do we find c? We use the full point. So where there is y, we put 1. Where there is x, we put -2. Then we can find the unknown c. So c is equal to 1 plus 6, which is equal to 7. So y is equal to 3x plus 7. This is the tangent line equation. To find the normal equation, you find the gradient of the normal. Now the gradient of the tangent multiplied by the gradient of the normal is equal to -1. This is known, it is 3. So 3 gradient of the normal is equal to -1. So gradient of the normal is equal to -1/3. So we'll have y is equal to mx plus c. I can now use this one. So that will be y minus y1 is equal to mx minus x1. So we'll have y minus, we pick the point, y1 is 1, is equal to -1/3. X is the x remains there. minus -2. So we have y minus 1 is equal to -1/3x minus 2/3. Okay. So we have y is equal to -1/3x minus 2/3 plus 1. So we get y is equal to -1/3x plus 1/3. So this is the normal line equation. And then we sketch. So to sketch this function, we need to have the turning point. So get back the first derivative and equate to 0 for us to find the turning point. So 3x plus 3 squared is equal to 0. This is the same as x plus 3 is equal to 0. So we obtain x is equal to -3. Pick -3, take it in the original function, we'll get 0. So we have the point -3, 0 as a turning point. Now we need to know whether it is minimum or maximum. So we go back to the first derivative and differentiate it again to obtain the second derivative. So we also have this view. In the previous questions, we did a test using the first derivative. Now here we also have an exposure to the second derivative test. So y prime prime is going to be 6x plus 3. Now in this derivative, where there is x, we put 3. Where there is x, we put -3. We get 0. So the second derivative is not telling us anything. This means that this guy, -3, 0, is a point of inflection because it is actually 0 of the second derivative. Remember, the point of inflections were found by equating the second derivative to 0. So if you tried it here, you would get x is equal to -3. So we can sketch this. But before we rush the sketch, we need to find the y-intercept when x is 0. So we'll have 3 to the power 3, which is 27. The x-intercept, equating this to 0, will get x is equal to -3. So we can sketch. So we have an intercept at -3. So the function is going to be of which nature? Of this nature. I've taken it far. I'll take time getting to the intercept. So,
I missed the point. How did you get to y is equal to 3 squared?
to 3 power 3.
3 power 3. Yeah, how did you get that?
So we are looking for the y-intercept, which is obtained by letting x be equal to 0. Since x is 0 on the y-axis.
Yes.
So you always substitute x is equal to 0 and then get the 3 to the power 3 in that case, because 0 plus 3 is 3, and the power remains outside.
All right, thanks.
Okay. So I want to sketch this thing, which is not nice. Saddle point. Go back to that sketch, yeah? Yes. Something like that. Where this is 27. Now we have a tangent equation, 3x plus 7. X plus 7 at -2. When you press -2 here, we'll get +1. So let me redo the sketch for the purpose of the line. The purpose of the lines. It's not easy to sketch this thing so that I can have a line, a tangent line. So how am I going to sketch it? Maybe something like this. Maybe now, yeah. Okay. So this is 27. So at -2. So this is -3. Then at -2. Just want a point, say here. The tangent will touch this. And it's supposed to be, no, tangent touches once. That's why I'm having trouble in sketching this thing. Okay. So this is the assumed straight line touching here at -2, 1. So when x is 0, this guy is going to be 7. So we're sketching this line on that same graph. Then we also sketch the normal line. When x is -2, what happens when x is -2? We just try. So we have -2/3 plus 1/3. That's going to be 3 -2 plus 1, now which is equal to there's a challenge here, which is equal to -1/3. So something is not right with this equation, because this point must come out when you substitute -2 there. So we're supposed to have
sir, I think the mistake was there on the y is equal to since x is equal to -2, so the y is equal to supposed to be +2/3 and not negative, because there's a negative on the equation and the negative on the x value. When you are solving for the equation of the normal line, yes, it's y is equal to -1/3x plus 3. Since x is -2, when the x in the -2 and the -1 cancel out, which will leave +2/3.
The negative came back because of the negative
That
1
was
over 3
outside.
after distributing it inside.
Okay, let's try this method. Y is equal to mx plus c. You see if it will land us on the same spot. So y is 1, negative 1 over 3, multiplied by negative 2, plus c. So we have 1 minus 2 over 3 is equal to c. So I think we're getting the same thing, 3 minus 2, which is 1 over 3. So it's still positive 1 over 3. So where now? Yeah. And the first one, m is equal to 3 makes sense because in here, this guy, when you substitute negative 2, you get positive 1. So it makes sense. But the other one should make sense as well, because we have used that point to get this 1 over 3. So why is it failing to work out? Can't understand. Oh, okay. It's not failing actually. It's us. So it's me who is failing. I wanted to include you. It's me who is failing. So it's y is equal to, since we have negative 1 over 3, and our x is negative 2 plus 1 over 3. Then we'll have 2 over 3 plus 1 over 3, which is equal to 1. Okay, so it's making sense. So I look for another ink. This one. So we have this as an intercept for the other one. Let me use the dark one. Okay. So this as an intercept for the other one. And then when x is 0, it's going to be positive 1 over 3. So we have another line cutting in this direction. Doesn't look like a straight line. It has to be a straight line. Okay. Something like this. So it's cutting at 1 over 3, positive 1 over 3. And this side, we can find the intercept where there is. So equate the whole thing to 0, this whole thing. So it will be positive 1. So that's the sketch. We have sketched the graph. We've put the tangent line and the normal line. So one thing that is clear is that the normal line and the tangent line, at their meeting point, they form 90 on other sides. We have questions.
Can you kindly repeat on the plotting? I was logged out.
So on the plotting, since we found the intercepts, so we found the y-intercept here. We found the y-intercept here, which is here. The x-intercept here, which is negative 3. This very x-intercept also came out as the inflection point from making the second derivative 0. So then we knew that nothing would happen there. The function would be increasing from the left and not stop increasing. It will just relax a bit at that point and then starts increasing again. So how do you know? You can use the first derivative test to determine the sign of it around -3 before and after. So you notice that because it is squared outside, the variable is squared, we have x plus 3 in brackets squared. So any value you take there, the output would be positive. So it's increasing both before -3 and after -3. So that's why the sketch in red looks like that. And then the tangent line remember tangents are always given at a point. So at -2, 1. So we have -2, 1 here. The tangent line of this equation would look like this line here in blue. And then the normal line will come in this into here. So this question it doesn't have nice graphs. So I'll skip B and go to C, which is x squared plus y squared is equal to 20 at 2, 4. So we use implicit.
Sir, before you go any further, may you please go back to the previous page? Thank you.
Okay. And then we differentiate here. So using implicit, we'll differentiate x squared and get to x. We'll differentiate y squared and get to y. But remember, y is a holding function of x. So we put dy dx. Derivative of 20 is 0. So dy dx is actually -2x over 2y. So dy dx is equal to -x over y. And then we pick that point for us to find mt, meaning the gradient of the tangent. So we'll have -2 over 4, which is equal to -1 over 2. So you substitute the whole point if you have even the variable y present in the derivative, in the first derivative. And then y is equal to mx plus c. Using the same point, y is 4, m is -½ x is 2 plus c. So we get 4 plus 1 is equal to c, implying that c is equal to 5. So y plus 1, these 2's here would cancel. Then this -1 will go the other side as a positive. So this is 5 actually. So we have y is equal to -½ x plus +5. This is the tangent equation at 2, 4. And then we said m normal is -1. Now we already have -½ m normal is equal to -1. So m normal is equal to +2. So we have y is equal to mx plus c. Y is 4, m is 2, x is 2 plus c. This is 4 minus 4, so c is equal to 0. And so m normal is, no, m normal had been found is 2, then c is 0, so we have y is equal to 2x. Then the sketch of this guy. Let's try to find from the first derivative. If you equate it to 0, you will notice that you have negative x over y is equal to 0. And this guy is only 0 when x is 0. So when x is 0, the derivative will be 0. So it also has y is equal to 0 as a critical number. So you can see that both variables are critical numbers, so it will be difficult for us to use all those principles. But we understand that x squared plus y squared is equal to r squared is a circle centered at 0, 0 with radius r. So this is a circle with radius root 20. So this is negative root 20, negative root 20, positive root 20. And then at 2, 4, at 2, 4, we have the tangent line. We have a tangent line it's tangent. First I get the question. So we have a family of curves that form the circle. So I haven't moved from that to that. I want to sketch here. So tangents are difficult to sketch on my side. But I've managed. It's a rough sketch. So no hard feelings. And then the normal 2x. So the normal will be cutting in this way. Actually, 2x. So hit there at the origin. Okay. So this is y is equal to 2x. And this is y is equal to negative half x plus 5. Don't worry, it just looks like that, but it's supposed to come and touch at some values in the x-axis. This is just a rough sketch. And that's how you have that sketch. Do you have questions? So I'll be able to share
I
the.
didn't get.
Sir, kindly repeat on the circle thing. I was logged out
Yes, sir.
when you started explaining.
So one thing you should know is that whenever you have x squared plus y squared is equal to r squared, where r is greater than 0, this equation is is the equation of the circle centered at 0,0 with radius r. So our question has x squared plus y squared is equal to 20. So the only thing we did is we just looked for r, square root. So we have r is equal to the square root of 20. And then we drew that circle there. That's all. So I was making a point that I'm going to share this in the group for those who had network challenges and for those who missed, and for us who may want to revise using this. You may not see the need now, but please keep it. The need may arise as we get closer to the exam. In case you have tension and you feel you need a voice note for you to be able to understand, you run through the videos. It's healthy. Have a good night.
All right, thanks. Have a good night too.
Okay.
Thanks,
Thank you,
sir.
sir.
Have a good night as well.
Okay.
Thank you, sir.
Thank you.
Mm.